Well, hello there, community. It's been a hot minute since we've done one of these, and I'm excited to be here. We're going to do something crazy. We're going to kick off Advent of Code, which technically started yesterday. And so we're going to do the kickoff exercise, day one, part one, in an iRule. Before we do that, we're going to look at our solutions in Python for Boo and I. Bring those guys on in a minute. Before we get started, I did want to make sure that everyone knew about App World 2025, February 27th or 25th through the 27th in Vegas. And so if you have not signed up yet, make sure you do. Join us there. The entire DevCentral team will be there. We'll have tons of great labs on all F5 technologies, as well as excellent keynotes, breakouts, and whatnot. So it's going to be a great time. We re-kicked off what used to be called Agility App World. Last year was our first year back in a while, and this is year 2 of App World. And so I'm excited about it, and I know the team is excited about it. So make sure that you join us for that. And one more thing before I bring the guys on. Later this week, I have Mike Wachter joining me. He's a SE manager for F5, and we're going to talk about the application study tool. And that is an observability platform, gives you insights into what your big IP infrastructure looks like. I remember way back in the day, I had a Cacti server. And yeah, if you know what I say by Cacti server means, you're old school too. And but I watched all my virtuals and CPU and memory and all that kind of stuff. And so the observability platform in Prometheus and Grafana in the application study tool, it's so much more than that. And so join me on Thursday. We're doing that at I believe 11 a.m. Pacific, 11 a.m. Central, 9 a.m. Pacific. It's in the show. If I have the time wrong, but join me Thursday with Mike Wachter. It's going to be a good time. And okay, so I'm going to bring on my buddies on the DevCentral team. Aubrey Boolam, how are you today?
Good. How you doing, man?
I'm doing well. So Boo, you have solved day one, part one, and you're hopeful for part two, right?
I'll be honest. While we were waiting there, I tried my part two answer, and it is still not correct. And I will willingly sacrifice my embarrassing code as a learning exercise if people want to help me fix this.
It's never an embarrassment. It's that's why I love these challenges. It's sometimes the challenge itself is hard. Sometimes just reading the challenge is hard. Like I'm on part. I was on when I stopped to do work-related things this morning. I got to part two, and I'm just reading it wrong, I'm sure, because one of the things it says, this can never be valid. I'm like, how can that never be valid in part two? So I'll get there with part two. But so let's kick off before, and Aubrey, you're here for moral support as we get to the iRules and color. You're going to be our color analyst today. You're going to be the Tom Brady of the broadcast.
I typically like to compare myself to Flava Flav from Public Enemy.
Okay. All right. So zingers, keep them coming. And anybody else out there, feel free to flame away in Python or iRules. And so this will be a good time. And with that, let's talk about the challenge. Let me add this back in so we know what we're looking at. And, I'll start here with the Advent of Code is every year they do a series of challenges, and it's always 2 parts. You get part one. If you solve part one, you get to move on to part two. And there are some speed runners out there that solve it in about 8.7 milliseconds. And I'm always impressed by them. There are people that have YouTube channels out there that analyze and walk through the challenges. And so for me, not being a classically trained computer scientist, there's a lot of things I can solve. But if the data set gets too big, I can't solve it because my code is not efficient enough. Or there are some challenges I don't even know how to analyze. And then there's some challenges I know what I want to do, but I don't understand the mechanics of the language to solve it. So being able to see other people walk through things, it just, raises everybody's level because you can see a unique problem that everybody is digging into. And so, it gives you problems to solve. And that's really kind of one of the biggest hurdles of learning to program is not knowing, not having a challenge to solve. So things like Advent of Code are really great. And there's another one that I just learned of that we won't talk about today, but it's Everyone Codes, and they have some different quests that you can do. And is that the link for the DevCentral forum for that? You're muted.
Sorry. Yeah, I made it not scrolling there. But yeah, so if folks hit that, you will find a thread in the water cooler that has all of our frustrations vented via message forums on there.
Okay, cool. Yeah, and our leaderboard is in there too. So if you want to join us on the Advent of Code for the leaderboard, you can do that. Okay, so here's the challenge. We'll start. It introduces kind of the whole thing. We won't talk about that, but let's start down here into the challenge. So upon pouring into the office, everyone confirms chief historian is indeed nowhere to be found. Okay. Throughout the chief's office, the historically significant locations are listed not by name, but by a unique number called the location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the two lists up side by side, which is our puzzle input, it quickly becomes clear that the lists aren't very similar. You can help the historian reconcile their lists. And so here's our test data. So we have the two lists, and the vertical column is list 1. This vertical column is list 2. And so, that is the data. So maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list. Then the second smallest left. Okay, so you're gonna order them. Either smallest to biggest, biggest to smallest. Within each pair, figure out how far apart the two numbers are. You'll need to add up all of those distances. For example, if you pair up a 3 from the left list with a 7 from the right list, the distance apart is 4. Okay. So in the example list above, the pairs and distances would be as follows. So it kind of goes through that information. Third smallest number in both lists, 3. To find the total distance between the left list and the right list, you add up the distances between all the pairs we found. In the example above, the distance of each pair is, if we look there, ordered, because these aren't ordered. It would be 2, 1, 0, 1, 2, 5. For a total distance of 11. So your actual left and right lists contain many location IDs. What is the total distance between the lists? And so that's my puzzle answer for part 1 yesterday. And that won't help you if you do Advent of Code, because that's unique to me. When you get your non-test data, you get actual data. All the data sets are unique to each player. So if you go and find an answer to somebody else's puzzle, it's not going to help you. And then we go down. We're not going to do part 2 today. Okay, so I think we know what we need to do, and so from here we can go and actually evaluate our Python stuff. You want to walk through yours first, Boo? You want to share? Okay, we got yours.
Yep.
Add that to the stage. Go ahead.
Okay. So mine will. Let me blow that up.
Make that bigger?
Mine is the example of poor coding. So let's. Oh, hold on here.
So I'm not gonna excuse mine from the idea of poor coding rules. Okay.
Okay. So I used a function from the math call, but so just ignoring that. So I've got my input file loaded, initiated a left and a right list, which I guess starts off as a string. But anyways, started a loop. So line for the file, numbers is what I grabbed. And so I took the line and I split it. And then I took each iteration, or sorry, it's split. So actually what we didn't look at was the file. So the input.txt is kind of 2 columns if you were to open that. And so the split will take the 2 columns. And so I have the 0 and the 1 column. And then I loaded them using append with, oh yeah, there's the example.
Give me a second, I'm just highlighting the data. Yeah, so in the file that like when you load that text in, it's just a string and it's got new lines in there and the white space between and that kind of stuff. So let me go back to your code.
Yeah, there's my input file. So it's got the 2 columns there. So I took that and I used the append, and so I loaded it as a integer, and then did left append and then right append. So I've got the 0 column and the 1 column, and then I did sort from there. And then I started off another variable called total diff, and then I used a counter here, and then I go for line in left, and then the diff is using this math function. So there's a math function called dist, and so the count is the counter that started at 0, and I got a diff between left and right, up the counter by 1, and then added that to total diff, and that seemed to work. Probably ways to do this in like half a line of code, but I took 22-ish.
No, that's great. Math.dist, I did not know that was a thing. There are so many collections within Python that I don't know them all, and I wasn't aware of that one, so that's cool. Let me unshare on my end so I can share the other my Python side. Go to StreamYard, present, share.
And for folks following, if you want to, my repo is public and my GitHub is just boolam. So very, very easy to find. If you just go to boolam, it'll be a repo that was just started yesterday and will probably end after 2 days.
Okay, so I'm not a speed solver, but I do like to make things a little easy for myself. So I am using this input called or this module called AOCD, which is a data import service. And if you get your session cookie out of the event encode site, then you can use this to pull the data down dynamically, so I don't have to save it into files. And then for each puzzle, I get the data. I'm using the datetime function to pick the day. So as long as I solve the challenge on the day of, this works. If I get behind, I need to manually change that. And then solutions, this part never changes. This code goes into the solve itself, doesn't change. It takes the data, it parses the puzzle input, and then gives me solution 1 and solution 2 to part 1. Then I return that solution. So this, all this stub code never changes. And then, up here doesn't change. It really is parsing the data and then the part 1 and part 2. That's where my solve. So parsing the data, I was much like you. I'm splitting that puzzle input, creating a left list and a right list. And, I'm implicit rather than explicit just because of long-term patterns. You did list, you actually used the list terminal or the list function instead of just what a list looks like. But I went in pretty much the same thing as you. I'm creating integers, appending those to the list, and then I'm sorting them and returning them. So that once it's parsed, I can pass that to both functions. In part 1, what I'm doing is I zip the data together. And what the Python zip function does is it creates a zipped list of each item. So I have those combined back into that ordered function. And then I just take so you use the math.dist. I just did, and this, this is a list comprehension. This does that for loop for you without creating all those variables. So what I'm doing is I'm taking the absolute value of one versus the other, which creates that distance. And and then for the list item, or for the left item and the right item in that zipped folder. So here's the Z, which I zip that data. And then for each of those values, I'm taking the absolute value of that, and that returns me a list. And then I just return the sum of those diffs. And that's my solution.
That's awesome.
And so any questions out there, any comments on for Boo or I in how we solved the problem? Now, you haven't solved step 2 yet. We're not really going to talk about it, but this is my, if you're going for a, and notice in this one, I do not have a list comprehension here yet. Sometimes the list comprehensions come to me right away and I don't have to think about them. Sometimes I still have to go through the for loop process, especially if I have a lot of if conditions or anything, but this can easily be recreated as a list comprehension too. So this would be also, that will end up being one line of code, like this one up here.
So basically, like my code was as if I had just printed it off and wrote it out with pen and paper compared to this.
Maybe. Okay.
I love it. Awesome, Jason.
All right. So now let's think about iRules, and I'm going to come over here and share VS Code on my other machine, because that's the one that's connected to my internal labs. Let me share from over here. Present, share. Where's my VS Code? There we go. And let me get that on screen. Okay. Can you guys see that?
Yes.
Okay. So I need to license my, so I have 2 big IPs. One, they're both in the same network together, so I can pass traffic to actually make the request. So I stubbed this out just so that we have something to start with, so I don't actually have to create an iRule and all that. But I'm in VS Code, and this iRule is AOC day 1, and we're going to return the solution eventually, HTTP respond, content, advent of code day 1, part 1, and what the solution is. So if I run that against my virtual server, we can see that I'm going to get an answer here. Eventually, we got to build this answer, right? So if we talk back through what we were talking about, we have to parse the data, right? That's the first step we got to do. And then what else did we do? I'm trying to look at my Python. Okay. We have to sort the lists, right? And then we have to zip the lists. And then we have to count the distances and summarize them. All right. So now it's any comments out there? Who's good at going from language to language? I am not. It's context switching is hard just in regular stuff, but when you're writing code, going back and forth between Tickle and Python is not super awesome. But we'll try to make this work. Okay.
No, it's like how when you try to do something in Spanish and your native language is English, you don't want to just think, oh, here's how I would say it in English. It's you go directly to here's how I would say it in Spanish. So that is
right.
hard.
Right. Okay. So we have a set list, set left list, right? So we're going to create our lists. You can keep, so in Tickle, you can do those empty, or you can, I could just do quotes if I wanted to. But if we're going to be explicit like Boo, explicit's better than implicit, right? Then we can create those lists and get them going. So what else do we need to do? We need to do, so I had a list comprehension. Boo, you had a for loop, right? We need the data. And so I can't pull that in an iRule. When rule init, and we'll just work on the test data because I don't want to try and format that. Let me look at the test data.
Left list is
static. Let's do static puzzle data. And then looking at that data, keep me honest if I mess up a variable here. Does that look right? Yeah, I think that's right. The 3, 4, and
There's
4,
no
3,
slash in the
2, and
next
5.
one. Well, yeah.
Thank you. 3
Sure.
and 9, and then 3 and 3. Okay. And Aubrey, will you watch comments if any come in?
Yeah, you bet.
Because once I start coding, I tend to tunnel vision. All right, and Boo, keep me honest here if I get stuck anywhere. You have any
I'll try.
insights and all that? But okay, so we're parsing the data. We've got our lists. So we can do a for each loop in Python. We're going to do, let's do location pair. That's what we're going to name what we're pulling out of the data, right? So split static puzzle data, and we want to split that on the new line, right? And then unlike Python with just the spaces, we actually have to use brackets in this. So I can set a location, like set locations, and we're going to split again, right? So location pair, and we can split. If we split on a single space, we should end up with, let's see. Let's just do let's see what we get here. And then we can, we're not at a solution yet, but let's just, oh wait. Let's leave that alone. We won't return it, but we can go to look at that when we say, or when we hit it. Or we can go look at the log files. So in fact, let's let me save that. See if we're at least at a point where it's going to save. Okay, merge is successful. That's saved. Now, if I can you have multiple terminals in
That I don't know.
Yeah, I think
VS
you can.
Code? Can you?
Yeah.
Do I just?
Yep.
There's like a side by side. Yeah, hit the side by side button. Is that what you wanted? They're right beside that where you're hovering over.
Okay, there we go. Yeah, it's just, okay. So SSH at LTM 17.
Yes, I'm sure.
Okay. Farlog LTM. Okay, so if I come back to my other one and we hit that curl again. Oh, so that didn't like that. Can't read static puzzle. Yep, that's got to name that correctly. Okay, so if we hit that again, that worked. And so, all right, so you can see we have 4 elements in that if we split on a single line. We could split on the exact pattern, but I'm not a fan of matching white space characters. So because we know what's that?
What about using tabs?
Well, you got to use what's there for the data. Okay, but if we're splitting on that single line, which we are, and we know there's 2 spaces, our L indexes, all right, are 0, 1, 2, and 3. So we need 1, 0, and 3 to actually append our data, right? So L append.
You were referencing the input.text is not using tabs when you said that, Jason. Just to clarify.
I was referencing what?
Because Aubrey asked about using tabs as the delimiter, but input.txt is not using tabs; it's using spaces.
Oh, correct.
Which
Yeah. My puzzle data does not have that. Yeah. Now I could reformat my puzzle data as I import it to do that. Okay, so 0 and 3 should append those lists, right? And so that should do it for making sure that our lists are in left and right? And then we need to sort them. So we can do a sorted list. Sorted left is, I think, let me see. I don't have a share of a web browser, but I think lsort. It doesn't match in the iRule editor, but lsort I think will work here. Lsort list. But we want that to be sorting as an integer, not a string. And then sorted right, lsort integer right list. Okay, so let's do a log here. Log, just to make sure we're on the right track. Left, sorted left, right, sorted right. Let's merge that. Okay, that was successful. We go, oh, we did something wrong again. Data publisher not found. Tickle error. Let's hide this. Can't read sorted list. Oh, if I typed correctly. Okay. There we go. And so let's hide that. All right. So is that, if we look at our original data, 3, 3, 5, 3, 9 for the right. I'm having trouble. Is that accurate or no?
3, 3, 5, 3, 9.
Is that not accurate? Let's see.
That looks odd to me. 3, 3, 5.
3, 4, 2.
Yeah, that's right.
Is that right?
Yeah.
1, 3, 3. Okay. Yeah. That looks right. Okay.
Okay, sorted. Yeah. Okay.
Yeah. So now the tricky part here comes with zipping the list. There's probably different ways to do it, but that's how I know to do it. So I don't think Tickle has a zip function, but we can create one because iRules support procs. How are we doing on time? Okay, 2:30. Okay. So let me come up here to the top and proc. So let me look at the Python stub for the zip function on this other. If I have two lists, I'm going to zip them.
I'm not sure I ever wrote a proc in iRules when I was an SE or as a customer either.
Okay, so we'll create a list because we need to zip a list, and so we're going to have two elements zipped in that list. We need a length, and we can do either one of these because. So I'm not adding error correction. I'm just assuming both lists are the lists length that they should be. So I can do either one. And then for set I 0, I less than, and that's where I take the length and then anchor I. Wow, it's been a hot minute since I've done an actual for loop in Python. instead of for each. I always like loop through, and technically I could probably do for each. We'll leave it at this for now. Okay. And so all I need to do here is if I have list 1 and list 2, I can append z list with a list of, I need the element of list 1's I, right? So I need index 1. Okay. So index L1 I and index L2 I, right? Because that'll pull out each one in order of the loop and then attach both of those things together. I don't need, and if I'm listing that, it should be good. Okay. That should work. Let me see if the proc saves before we actually use it. Yep. Okay.
And
all
of
right.
course,
So to actually,
if you are out
Go
there
ahead.
watching, please feel free to put in a comment and ask a question. We're here.
Okay. So to actually zip the lists, so a zipped list, and this is another thing, like when you're writing iRules, how big your variable names matter because it takes more memory space. So you might not make these quite as large, and especially if you're writing a really, really long iRule, your character count matters. This is not a really, really long one, and it's not going to take up a big memory footprint. So using names that mean something matters in things like this. But when you want to highly optimize things, you can like create way shorter for that. So with a proc, you can call it, I'm going to call it, do a relative call here. Normally you kind of want to like call it by the folder and the explicit name of the iRule, but I'll just leave it as is. Okay. And then I want to pass my sorted lists, right? Sorted left and sorted right. And so that should create my zipped list. Okay. And let's see how that works. Are we going to save here? Yep, we merged successfully. So let's try to run that. Still no solution, but no error. And then that is a blank. Oh, it helps if you return data. So some functions in iRules, when you just turn procedures, you just want it to handle and do something. But if you want data returned to work on, you actually have to return data. So, all right, so do that. Still no failure. That's good. And then there's our zipped list. So 1 and 3, 2 and 3, 3 and 3, 3 and 4, 3 and 5, and 4 and 9. Okay, so that looks good, right? We can go on. Now we got to do the counting. Okay, and so looking at my Python, how did we do that? I did a absolute value with a list comprehension. We can use absolute value in Tickle with an expression. So looking at let me expand my list comprehension here for a second. Okay. So if I set my total distances, and then I'll do another for each for that. Zip list, is that okay? All right, so how'd my absolute value work again? Okay, yeah, I'm just doing an expression for the absolute value for each one, and then I actually need to evaluate the total distances as well in this loop. So I can do a location diff with an expression, and then we do absolute value. Actually, this is the exact same keyword, and then we want to minus that, and then so you can do here in the location we can do a get field, which is less, or you can do a L-index split. They both evaluate to the same. I've done some performance stuff, and it's not that bad. So locations 1, and then so basically the get field out of locations. I'm using this as my split function, and I want the first one. So get field is 1 indexed, and L index is 0 indexed. So important to know that. But get field locations and 2, and so that should set that location difference. And then we want to set the total distances. We want an expression here, and we're going to take we're effectively just going to do add total distances to the location diff, right? So we can do total distances plus location diff, and that, so I can hide these logs. We don't need those now. Okay, and Boo, what was the test data answer? It was 11 for this one. I think I'm a couple challenges in, so I don't remember quite exact, but is the test data for this one 11?
Yes.
Okay. Without doing logging, we're just gonna go for it. Well, that merged successful, so that's a good news. That's a good first step. All right, so let's go back here. And boom, 11.
Wow.
Okay, so we had some bumps along the way, some typos and all that. But yeah, so part 1, at least I have no chance at solving a lot of these challenges that come in iRules, because the ecosystem in iRules is limited, right? You have to build the functions that a lot of languages just have built in. And to be fair, a lot of modern Tickle does have some of these functions built in, but the larger included libraries you can't build into iRules. They purposely kept the iRule binary small so that it's highly performant, and it doesn't take up a lot of memory footprint. And so but you can build stuff like proc, and I had an exercise with an SE recently where we went through and migrated a lot of Tickle's IPv6 library into an iRule procedure library. And so then you could call all those functions from your other iRules, and they behave exactly like they do in modern Tickle. So any of the Tickle packages that you can code as procs, they're available to you. You just have to do the migration to make them work in iRules. But anyway, that was fun.
That's awesome.
Can't believe it. Yeah, day 1. Part 1 worked anyway. I may make part 2 work later. I don't think part 2 is any more challenging and just required a slightly different approach. So I may do part 2 and then upload that to a gist and share that in the Advent of Code forum, which you had right there. So come join us at that link. I can drop that in the chat as well. So that's it. Did you put that in the chat already?
I did, but could drop it again just to get it at the top.
Okay. So there you go. Join us out there at DevCentral. We'll be kind of talking about it. again, Advent of code particular is hard. It is very heavy on the computer science side. Not necessarily just can you solve the problem, but can you solve it in a way that your Mac or Windows machine won't tip over because maybe you need a little bit of extra computing power for what you're working on. But okay, so Aubrey, you're going to do a Rust implementation by tomorrow, right?
Definitely not. It's not happening.
Yeah. Yeah, I remember, was it a couple of years ago, you started like day one, you actually did it in Excel. And I was like, wow.
Yes, that was the programming that I knew at the time. So
yeah. Yeah.
I kind of want to do it in Bash or like with awk.
There you go. Yeah.
I will, I'll evaluate all pull requests that come in to fix up my code. And my GitHub is just my name. So feel free to go in and trash it and leave comments and leave me a friendly pull request with corrections.
Yeah, I have my GitHubs out there too. It's just Jason Rom, one word. And I think I updated it this morning. So part 1 and part 2 of Python is out there. Maybe I'll just merge in my iRule version in that same advent of code. And if I decide to solve any more in iRules this month, they'll be out there on the particular day. But anyway, gentlemen, it's been fun. And thank you everyone who joined us. And we will see you. Hopefully, come join me on join me on Thursday at I think 9 a.m. Pacific to walk through the application study tool. It'll be a good time, and I think that you will be impressed with what insights it's going to bring for you in your environment. So, with that, thank you so much, and have a great month. If we don't see you before the new year, and register for App World. We want to see you in person in Vegas. Take care, everyone.
See y'all.